Hi, my name is Kevin O'Connor,
I'm Kara Clark.
and we're going to take you through the steps of the California Rapid Assessment Method for bar-built estuaries.
Our example site is the Waddell Creek Lagoon in Big Basin Redwoods State Park. The majority of the watershed upstream is state park lands. However, there are private inholdings with agriculture as well as logging and rural homes.
Additionally, this site is home to several special status species, including coho salmon, steelhead, tidewater gobies, and red-legged frogs.
Enjoy the training. Bar-built estuaries form at the mouth of coastal rivers and streams. These systems are seasonally tidal. Some times of the year, they have full tidal action from the marine environment. At other times, a sandbar forms and impounds a freshwater lagoon inland of the sandbar. They can be hypersaline during drought years or completely freshwater when the freshwater inputs dominate. This system, Waddell Creek, is a bar-built estuary. The AA will extend from the beach side of the lagoon where the vegetation starts, where the vegetation covers at least 10% of the area. You'll extend from there upstream to the transition to riverine wetland. You will include the backshore and any overhanging vegetation that covers the backshore. At this assessment area, we included most of the marsh plain on the north side. However, we did not include the marsh on the south side because the channel is not safely crossable. You don't want to cross a channel that is wider than 50 meters or uncrossable during low tide. We extended the AA upstream to the transition to riverine wetland.
The aquatic connectivity metric for bar-built estuaries is composed of 3 submetrics that take into account the influence of the riverine, marine, and adjacent wetland environments. Those 3 components are scored equally in the overall metric score as an average. The first submetric is stream corridor continuity. Use your aerial image to assess this submetric. With your AA drawn on your aerial, draw a line 500 meters long upstream from the transition between riverine and estuarine environments. Look for all non-buffer land cover segments along that line and add them up. Refer to the rating table in your field book for the appropriate score. The second submetric is adjacent aquatic area. Again, use your aerial image to assess this submetric. Extend 4 lines emanating out from the edge of your AA, perpendicular to the main flow of the wetland. In general, these lines will extend north and south due to the east-west flow of most coastal streams. Measure the percentage of each of those 4 lines that intersect an aquatic feature of any kind. Take the average of those 4 lines and then refer to the rating table in your field book for the appropriate score.
Bar-built estuaries rely on the marine environment for sediment and nutrient supply. This can be altered by human actions, such as coastal armoring or beach cleaning. The kelp on the beach provides important nutrients to the lagoon itself. This metric is measured by looking at alterations to sediment and nutrient supply. Here at Waddell Creek, we have coastal armoring upstream. However, it covers less than 500 meters of the coastline adjacent to the lagoon. The beach is not actively cleaned or managed. Therefore, for this submetric, we get a B.
The buffer score for bar-built estuaries is composed of 3 submetrics, that being the percent of the AA with buffer, the average buffer width, and the overall buffer condition. To assess the first submetric of buffer, that being the percent of AA with buffer, use your aerial image. Draw the AA on your aerial and look along the perimeter of that AA for any non-buffer land cover types. Take the remaining area, and that is the percent of your AA with buffer. Refer to the rating table in your field book for the appropriate score. For the second submetric of buffer, the average buffer width, use your aerial image. With the AA drawn on the aerial image, place 8 lines equally spaced around that AA where buffer is present. Draw them 250 meters long or until they encounter any non-buffer land cover type. Take an average of those 8 lines and refer to the rating table in your field book for the appropriate score.
Buffer condition is assessed in the area where buffer is present. Here at this site, we have a nice buffer behind me with native shrubs. The buffer is broken by the highway. However, there's an access road on the north side of the lagoon, which is included in the buffer because it does not have heavy traffic. It does have some human use, which brings down the score a bit. Therefore, we give this site a B score. The water source metric measures the sources of fresh water to the assessment area. Natural sources of fresh water can include riverine inflow, precipitation, or groundwater. Anthropogenic sources could be agricultural runoff or urban storm drains. To assess the water source, look at the aerial imagery and view the watershed upstream of the lagoon within about 2 kilometers. Here at this site, there is some agricultural activity in the watershed. However, it covers much less than 20% of the watershed upstream. So this metric gets a B. The hydroperiod of a wetland is its characteristic frequency of inundation or saturation. In barbel estuaries, this is governed by the opening and closing of the mouth, as well as the migration of the lagoon system across its floodplain. We assess this metric by looking at anthropogenic alterations to the mouth formation dynamics and to the migration across the floodplain. Many barbel estuaries have been altered by road grades or bridges, which restrict the migration. They've also been altered by management actions on the mouth opening and closing, such as artificial breaching or artificial closing of a sandbar. Here at Waddell Creek, the sandbar is allowed to freely open and close. However, there is a road grade and a bridge which restricts the migration of the mouth across its floodplain. Therefore, we give this metric a B at this site. Hydrologic connectivity describes the ability of water to flow into or out of the wetland. This allows rising waters to inundate adjacent transition zones. This metric is scored by looking at the wetland that contains the AA and determining the proportion of that wetland, which is restricted by unnatural features, such as levees, concrete walls, riprap, or road grades. In this particular assessment area, there are some unnatural features, which restrict the movement of rising waters. To the south, there's an access road, which separates a pond from the main lagoon. To the west, Highway 1 forms a berm, which also restricts waters. The anthropogenic restrictions to the movement of water exist for less than 50% of the boundary of the wetland that contains the AA. Therefore, this metric gets a B.
To assess structural patch richness, first familiarize yourself with the overall list of possible structural patches found in barbel estuaries. Then walk throughout your entire AA, looking for indicators of those patches that are at least 3 meters square in size. Check them off on the list. Then refer to the rating table in your field book for the appropriate score. Rack is an accumulation of natural and unnatural debris along the edge of your wetland, and it can contribute detritus into that wetland and increases the overall physical complexity of the shoreline.
A pan or pool on the floodplain is a depression which may have ponded water or it may be dry at other parts of the year. These are important habitats for migrating waterfowl and for amphibians. To find pans or pools in your assessment area, you must thoroughly walk the entire area. However, they may also be visible on aerial imagery.
Hummocks are mounds formed by the accumulation of sediment and biotic material around the base of plants, along tidal channels, and on marsh plains.
Large woody debris exposed above high water in the channel is important habitat for species such as pond turtles or birds. It provides a perch that is isolated from the water and not open to predation. It can also provide shade and a resting area for fishes.
Large woody debris and logs on the marsh plain provides important habitat for amphibians as well as insects, and increases the overall complexity.
A pool or residual embayment is found in the main channel of the lagoon. This is important habitat. It provides refuge and a transition for salmonids as they go out to the ocean. The residual embayment is still ponded when the mouth is open.
Submerged aquatic vegetation provides important habitat in bar-built estuaries. Examples of vegetation types include Elodea or Zostera, such as eelgrass. These plants are rooted under the water, but don't usually grow high enough to intercept the water surface. Submerged aquatic vegetation can influence nutrient cycling and provides food and shelter for fish and other organisms.
A snag is any standing dead tree that is at least 3 meters tall and 10 centimeters in diameter. Snags provide a perch for raptors or other birds and can be a nesting habitat for woodpeckers. A swale is a broad, elongated linear depression which can convey flood flows. They are found along the shoreline or on the floodplain. They contribute to topographic complexity and they add to the movement of water through the wetland.
Upland habitat, safe from wintertime flooding, can provide overwintering as well as nesting areas for turtles, snakes, and amphibians. After walking the entire AA here at Waddell Creek, we observed 9 structural patches. This gives us an overall score of C for this metric.
To assess topographic complexity, walk the entire assessment area and observe the macro and micro topographic features. Some examples of macro topographic features include large secondary channels, benches along the main channel, or backwater habitats. Microtopographic features could be things such as hummocks or small depressions within the marsh plain. Walk at least 2 transects and draw a sketch of the features that you observe. Compare your sketch to the diagram in the field book and assign a score. This assessment area has a variety of microtopographic features in the marsh plain. It has hummocks as well as remnant channels. However, it does not have extensive secondary channels or backwater habitats. We suspect this is due to sedimentation of the marsh plain over the last century from historic logging practices. The marsh plain has filled in and eliminated those habitat features. We have some complexity here, but not enough to give it an A score. We assign this wetland a C score for this metric. The plant community metric is composed of 3 submetrics: the number of plant layers, the number of codominant species, and the percent invasion. Fill out the plant community worksheet and record the species that are codominant. This worksheet will allow you to score all 3 of the submetrics. In this AA, we have 2 plant layers, a medium layer, which is between 0.3 and 1 meter, and a tall layer, which is between 1 and 3 meters. This gives us a C score for this assessment area. Here are some examples of the codominant species at this site. There's a rush, a marsh baccharis, and a Pacific silvertip. The total number of codominant species here is 7, so it gets a B for that submetric. The percent invasion at a site is measured by calculating the proportion of the codominant species which are invasive. The invasive status is based on the California Invasive Plant Council list. In our assessment area at Waddell Creek Lagoon, none of the codominant species is invasive. We have 0% invasion, so we get an A for this submetric.
Horizontal interspersion is the variety and interspersion of plant zones. Zones are obvious assemblages of species or monocultures of single species. They have constant assemblages throughout the AA. They're often arrayed along gradients of elevation or moisture. To assess this metric, look at the assessment area in plan view or from a bird's eye view and sketch the zones that you see present in the data sheet. Compare your sketch of plant zones to the diagram in the field book and assign a score based on this diagram.
There are 2 potential ways to assess vertical biotic structure in bar-built estuaries, depending on the topographic setting and the dominant plant community. In broad marsh plains, such as you see here, you're going to look at the entrainment of living vegetation, detritus, or litter. In more confined systems, you're going to look at the overlap of plant layers and assess vertical structure in that manner. To assess vertical biotic structure at this assessment area, we looked at the entrainment of living vegetation and litter across the entire marsh plain. At this site, you can see that there's a very dense canopy across almost the entire area. As a result, we gave it a score of A for this metric. We hope you enjoyed the training and found it very informative.
We'd like to thank Tim Highlands with the Santa Cruz State Parks District, as well as Big Basin Redwoods State Park.
For more information, please see our website.